The diagram below shows a block of mass 6 kilograms on a rough table attached by a light inextensible string. So we've got block A here attached by a light inextensible string. That means it stays the same length. The string goes over a light smooth pulley, that means there's no friction on the pulley, which has block B and a mass of 8 kilograms attached on the other end. Draw separate diagrams showing the forces acting on blocks A and B. If block A does not slip, find the tension in the string and calculate the friction force acting on block A. Write down the resultant force action on blocks A and B if A slips and accelerates. Right, forces on block A. So here we've got block A. We've got the weight, which is going to be 6g newtons. We've got the normal reaction to that, which is r newtons. And because there's no movement this way, the block does not move vertically, so therefore r and 6g must balance. So we've got the tension in newtons there. And then we've got a frictional force acting against the possible way it might slip. Okay, forces on block B. So here we have block B. It's suspended by the string, so it's going to be the tension going up, and then the weight acting downwards. And then let's have a look at the forces on the pulley. Forces on the pulley, so here's our pulley. We have a tension going this way and this way acting on the pulley. The tension are equal on each side of the smooth light pulley. Because it is smooth and light, there is a reactional force here to the where it is joined to the table. Right, if block A does not slip, find the tension in the string and calculate the friction force acting on block A. If block A does not slip, then the forces on block B are in equilibrium. So if we look at block B, okay, if this is stationary, does not move, then we can say that 8g minus the tension is going to be equal to 0, which gives that the tension is 8g. As the tension is the same throughout the system, and considering block A, so we're going back to the diagram of block A, then T minus F must be equal to 0, and therefore F will be equal to T, which is 8g, and therefore the friction force is 8g towards the left, so it's going to act that way. Now the final part, write down the resultant force on blocks A and B if A slips and accelerates. So the forces are now no longer in equilibrium. So if we look at block A, the resultant force, so if it's slipping that way, it will slip that way, then we can say that T minus F will be the resultant force, so that these two are no longer equal. There will be a resultant force, and it will be moving towards the right. And then if we consider block B, the resultant force this time will be, because it's moving downwards, it's slipping, then we can say that 8g minus T will be the resultant force as it's moving down. And this will be moving vertically now downwards. Okay, so this has been a video to show you two blocks suspended over a pulley system on an end of a table. I hope you've understood, and I thank you very much for watching.